it going? Is this our fearless 5-some? All right, any questions before we just keep forging through this list? All right. Well, so we left off with scanners and print writers and such. So scanner is another one of those classes you want to definitely know how to use, right? So you construct it with system.in if you want to scan from standard in. And mostly you just need has next line and next line, right? That lets you do what fgets does. It reads in everything up to an enter and returns it as a string. You can also construct a scanner off of a file. So you can make a scanner with an argument of new file, parentheses, you put in a path name to a file as a string, and if it can open that file, it will let you read from that using next line and next. That's got to go in a try catch block because that can throw an exception if the file can't be opened. And then print writers go in the other direction, so we don't need a print writer for standard out because we can just say system.out.println. But if we want to write into a file, we can construct a print writer with new file path name, and then we can do that print writer .println or .print or any of the other methods to generate output, and those go into the file. And one thing to keep in mind is this business of buffered I/O, right? So print writers are buffered output, meaning you say print this, print this, print this other thing, print this other thing, and none of that may actually be in your file yet. It's saved up until there's enough to make it worthwhile to actually write it out to disk. If you call the flush method on the print writer, that will force it to write everything out, even if there's only a few bytes to write. Or if you close the print writer, that will force it to flush everything out. If you just exit the program without doing either, your output may not actually end up in your file. So you get this empty file and wonder why. So that's buffered output. There's this whole hierarchy of input-output.
I just grabbed a really cool picture of it. There we go.
Right, so there's buffered streams and there's data streams, and those are built off of file input stream, byte array, output stream, and so on and so forth, and those are derived from input stream and output stream, and those are objects. So there's this whole hierarchy of these different ways of doing input and output, and different characteristics to them. The only thing we've used in this course was scanner for input, print writer for output, right? And that's enough if you just want to read some things in or send some things out. But it may not be the one that you would actually pick in say, you know, a deployed application where you care about performance or resource use or something. So sometimes we want very low level output. Typically if we're talking to another computer, right, we want to be able to write an integer and just put 4 bytes into a file and there's our integer. If we're writing to something that a user is going to read, we want to write an integer, we want to write the ASCII code for each character, or maybe a Unicode coding for each character so that it's human readable, right? Sometimes we only care about efficiency, so we would buffer up our output. Sometimes as soon as we write 1 byte, we want that byte delivered, because we may be talking to a server that responds to single byte commands, and so we might want an unbuffered output method in that case. So depending on your problem requirements, right, you'll encounter lots of different ways to do input and output. But for us, we're fine with just scanners for in, print writer for out. That's certainly enough, and that even worked for sockets. So it's plenty. All right, so exceptions and exception handling. If you don't do anything else and you get an exception, you just get an ugly message from the JVM saying exception, gives you a stack trace, and your program exits. So if you've got a set of code that you think might throw an exception, you can put it in the try block, right? And the general setup is try, and then some statements that you want to execute. catch, some statements to execute if an error occurs, and then otherwise, or finally. Right, so your try block runs. If nothing bad happens, you come down and you execute your finally block. If you're executing your try statements and an exception occurs, you'll jump down to a catch block, provided you have an argument here with an exception type that matches or is more general than the exception that occurred. So every time I've done this for you, I've said just exception, which means any exception is going to match this. And this is just a variable, an object, to take on the value of the exception that's passed to this. You can use that to find out what happened. But you can have multiple catch blocks. You can catch EOF exception, you can catch array out of bounds exception, and so on. And then the odd thing, if you have a return statement in your try block, it still comes down and it does the finally block before it returns. That's just a weird Javaism. I usually try to keep your try blocks as small as possible. Don't put it around your whole program. Put it around like the 1 or 2 statements that you think might throw an exception. Alright, so swing and Gooeys and graphical things. So I'm not going to ask you to know the details of the graphics class, the details of what Eclipse writes for us when we create a JFrame and we put a button on there and a text. It makes all this code for us, right? I don't expect you to reproduce that code. But I'd like you to understand that code that it makes for us as far as how we can work with that. So for example, if I create a button and then I right-click in Eclipse and say, let's add an event handler for action performed, it drops me into a set of code. It says it's a button listener. And what I want you to be comfortable with is the fact that I can put code in that block, and now if I run my program and I hit the button, that code gets executed, right? So basically what you did for making Gooeys, okay? The other thing we did was we overrode the paint method. So typically when we make a JPanel, right, we might make our own class called MyPanel, and we would say this is going to extend a JPanel.
Did we do that in Eclipse?
Yeah.
Oh, we did it in IntelliJ.
We might have done it in IntelliJ, but then we gave up on IntelliJ. I think I did it in Eclipse also.
I recall us doing that as it is.
Yeah.
Created a very colorful little snake.
Oh yeah. So there's a MyPanel that has everything that a JPanel has in it. One of the things JPanel has in it is a method called paint, right? And it's a public void paint, which takes an argument, which is a graphics object. And so if we write our own public void paint inside MyPanel, it'll override the paint method in the JPanel. Okay, so this panel, any time that something happens that causes it to need to be redisplayed, for example, if another window is placed on top of it and then removed, or if the window is resized, it needs to be repainted, the system will call the paint method in this class, right? Since I've overridden paint with my own, it's going to call my code, and this is where I can put things like g.drawOval, g.fillRectangle, and so on. Okay, and I'd like you to know the basic things that you can do with a graphics class: draw an oval, draw a rectangle, fill an oval or rectangle, draw a line, right? There's a lot in there. I don't need you to print out the whole documentation and put it in your notes. I don't need you to memorize it, but just know that you can do things like draw a rectangle, fill an oval, and so on. And so the main way that we end up using this is that, remember, we can't actually paint from anywhere in our code. We can't inside our button listener say, let's go ahead and draw a line, because we clicked the button. We can only paint from the paint method. So if we want to paint in response to a button press, what we do is in the button press, we set something up in this class, right? Set a flag or a field or something, so that when paint runs, it'll do whatever we want it to do, draw a line or draw a picture of a mouse or whatever. And then we call repaint, right? And repaint we're allowed to call anywhere. And repaint basically states I would like paint to be called, and then shortly thereafter the system will call paint, and it'll run our code and it'll do our painting for us. So there's kind of this two-step process to displaying things graphically. The first is to do some kind of setup so that the next time paint runs it does the right thing, and then we make a call to repaint, which eventually causes paint to run.
How resource intensive is paint?
I don't think it's particularly resource intensive.
So you could use it to like repaint every millisecond or something like that to make something look like it's moving?
Yeah, but you can't force it into a particular repaint, a particular, frequency of calling it. But that would be interesting to do actually. Just put repaint in the while loop, and inside paint just print out the time or something, or save the time to a file and see how often it gets called.
Yeah.
But yeah, you can definitely do animation like this.
All right.
And it's important because we could do animation by just putting a while loop inside here, but that's not going to work, right? We can't stay inside this method. We have to get in, paint, and leave.
Repaint after that.
Yeah, because it's part of a larger process, and if we just sit here in a loop, our buttons aren't going to work, and so on and so forth. Do you have a question?
When you said setting up paint, you just have like the code inside of paint before you call repaint, right?
Yeah.
I wasn't sure if you know like another method or something.
Well, like for example, if we wanted to light up a pixel wherever the mouse is, right? We can make a listener that says when you press the mouse, run this code. We can't say draw a pixel in there, but we could say let's save the XY positions of the mouse somewhere in this class, and then call repaint. And then repaint will call paint, and paint will look for the XY positions, draw that dot. All right, so most of the stuff that we did with Swing is basically event-driven programming, right? So an event occurs, a mouse click, a keyboard press, the window gets resized, something, and it causes code to execute, right? As opposed to writing a loop that says, while true, if the button is pressed, do such and such. Okay, so mostly we're not sitting CPU bound, mostly we're just in a kind of wait state, waiting for an event to happen, and then we write listeners, or Eclipse writes listeners for us, right, that are called when these events occur. So we make mouse listeners, button listeners, resize listeners, and so on.
When you have a listener, is the CPU just like flipping back to the listener real quick, really fast, or how does it actually interrupt?
So mostly it's ignoring our code, right? And it's just doing its thing. It's updating the clock and the weather and all the other stuff. The operating system is interrupted when the mouse moves, right, or a button is pressed. And the JVM registers itself with the operating system in some way to say, let me know when these events occur. So part of the JVM fires when you hit a mouse button, and it has data structures that say, here's everybody who needs to be notified when a mouse event occurs. So when you implement a listener, right, you basically add yourself to this list of things that should be notified, and then it basically just makes calls to your listener code.
So if you were doing it in something like C, where you don't have the JVM, how would you?
Well, so I mean in C we can definitely poll, but we don't really want to do that, right? We don't want to just sit there and keep checking the mouse buttons and the keyboards and so on and so forth. So you can set up some version of interrupts in C, right? You can get down to the lower level behavior, but it's definitely trickier. And I'm trying to think how one actually does that.
Well, there's libraries that do stuff like that for you, but
There are libraries that do stuff like that for you. I'm wondering what they do underneath. I'm pretty sure there's a way to set yourself up effectively as a listener, though. To say, interrupt me when this happens. But I have to go back and like relearn that. That's a good question. Now in assembly language it's easy, right? Because that's all you've got is the hardware. So, you know, you've done 270 engineering?
I'm in 250 right now.
Okay.
So I just finished this.
So engineering 270 will set this up in assembly language. And we'll see, for example, you can set it up so that this pin over here on the chip, if that gets 5 volts on it, stop what you're doing, start executing this code. And we go through a lot of gymnastics to set that up. But once it's set up, anytime that voltage goes to 5 volts, we start running this other code. It basically calls it, and when we're done, we go back to where we were. So now you can put a switch on there, and if you flip the switch, you jump into this code that, I don't know, turns on a light or something. And it basically goes in the background. Whatever else you're doing, this suddenly happens, and then you're back to where you were. All right, we talked about threads, and the main way that we did threading was to extend the thread class. So another example of class extension. So class T extends thread, and then all your code for the class. So I can put whatever I want in this class T, but it also inherits a bunch of things from thread. Okay, and one thing it inherits is a method called start. And if I don't write my own version of start, which I don't want to do, right? If I call start in a T object, it's going to run thread start method. And what starts thread method does is what thread start method does is it creates a new thread, new process, and then it calls public void run with no arguments. So in my class, I'll actually write a run method, and when I start this thread, it'll run whatever's inside here. So in my main class, I do something like T right, I make an object of type T, and then if I say T.start, that basically gets T.run to go in a separate thread.
Is this the most common way to deal with threading, though?
As opposed to implementing runnable.
No, to just extend a thread on your...
It's either that or you implement runnable. Kind of the same thing, but the only way I've done it in the board is extending thread. So that's the only way that I would need you to know, but if you do it by implementing runnable, that's fine also.
Wouldn't it be my thread dot start?
Yes, thank you. It's not static, exactly. So my thread.start. I didn't mention back here, and I probably should have, the concept of super. So anytime you extend a class, any methods that you write in this class override the original method. Right? If you want to get to that original method, you can do it by using the keyword super. It's kind of like this for the original class. And with paint, typically the first thing we do is we call super.paint with whatever the graphics object is. And that runs the whole paint method that comes with a JPanel, which sets up the background and the borders and all that other stuff. And then after we do that, we go ahead and we say, oh yeah, and I want to draw a picture of an elephant dancing across the screen. So you put that afterwards. And so same thing in a thread. If we wanted to run something from the thread class and there's really nothing in there that we would want, we could say super dot, and that would get us to. So any class extension that applies. And since this thread, right, everything's a thread, since this thread is creating this thread called my thread, right, I have access to whatever's visible in my thread. So I could do something like my thread dot set flag. Right, and as long as there's a method in here called set flag Boolean that's public, I can get to it like that. So since I'm creating the thread, my thread, it's really easy to get to fields and methods in there. If this new thread wants to communicate with the old thread somehow, you got to set that up yourself. And a typical way to do that might be in the constructor. And I could pass it this, which is me. So if this is like class main, I could have a constructor public my thread or public T, and I could give it an argument of type main, and I could have a class variable of type main called my parent, and then in the constructor I could save that argument as my parent. And then in here, if I want to get to something inside the main thread, I could say, you know, my parent dot set flag or whatever. But you got to set it up yourself somehow. But it's just objects, so you can pass around identities of objects, right? If you make multiple threads, you can tell them all who you are. You can tell them about each other. It's totally up to you. And the slightly odd thing is the keyword volatile. Right, so if you have a variable, a field in here, and you want to be able to access it from somewhere else, mark it as volatile. So volatile Boolean flag, for example. And that basically short circuits the caching. It makes sure that if this changes in one thread, every thread will see the changed value. That's just a detail, but it might save you some frustration down the road.
Can you make this generic so you can pass it any object?
Make what generic?
You said main parent. Can you say like some kind of generic object there? So
Yeah, you could make this generic. You could have a my thread that takes a generic argument, and then it could, if that made sense, yeah. Yeah.
You said volatile makes the variable independent of.
Volatile makes sure that if I have multiple threads reading a variable, that they're all going to read the current value of it. So this was this quirk that I tried to demo and it didn't work, and this turned out to be why. So say I have a Boolean flag in here, okay, and I try to read that flag from another thread. I may not read the actual value of it, right, because each thread keeps a local copy of memory, and it may save the value of this variable the first time I use it, but if it changes in here, I may not see that change. So if I mark this volatile Boolean flag, it says that any thread that accesses this should always come back and read the actual value and not keep a local copy of it. So it costs you a little bit of efficiency, but it makes it work. So that was this business of passing this to the constructor so a thread can communicate with its creator and sharing data among threads. Synchronize. So synchronizing is a way to control if two or more threads might be trying to execute the same code or access the same object. You can manage that by using synchronized methods or the synchronized keyword. So you can say, once I start this block of code, nobody else can run this code. Right? So this was the voting program with Yoda and Darth Vader. If it matters, right? Now, if everybody's just reading, that's usually okay. If one person is writing, that's okay. But if potentially two threads are modifying something, you probably don't want to do that at the same time. Right? Linked list, for example, you're trying to insert and someone else is trying to delete. They might delete the node right before where you're trying to insert, and your pointer's getting messed up. So you would synchronize and you synchronize on an object, and whoever tries to synchronize first, they basically use that object as a lock. And they say, I've got the talking stick, nobody else can do anything until I'm done with this. And then the process that's trying to also synchronize will basically wait until that resource is released. And this is one of the things we need to take into account when we have multiple threads. There's other things such as deadlock. Okay, so deadlock is when you have, for example, two processes, each waiting for a resource that the other process has. And neither process is going to give up their resource until they get what they're waiting for. And so they're basically stuck, right? So two people trying to pass, and neither is going to move until the other person gets out of the way. Well, if neither person moves, right, or trying to get through a doorway, you can't both get through, so one of you has to take a step back. And if neither is going to do that, you're both waiting, right? So that's a deadlock. Live lock is pretty similar, but basically the state is still changing, but you're still stuck, effectively, right? So, so you're both trying to get through a narrow hallway and you can't, so you both take a step back, and now you try again and you're still stuck, and you take a step back and you're still stuck. And managing that is just, it's tricky. It's just knowing sort of what the processes can do and coding accordingly. So sockets, which was the last thing we talked about. So server sockets and sockets. Server sockets are created first, and they're bound to a port. So they're sitting on whatever machine you're running on, and there's an IP address associated with the machine, and there's a port number which you specified when you created the server socket. And it has an accept method. And once you call that accept method, you basically wait until somebody else creates a socket somewhere which is bound to your machine's IP address and that socket's port number. Okay, once somebody creates a socket like that, they're basically trying to connect to your server. Accept will come back and it'll return a socket number which has been created and connected to the socket that made the connection. So now you have a pair of sockets, and you can use those to communicate, right? And they could be going across the network from one machine to another. So once you have a socket, you can get input streams and output streams, and you can use those to make scanners, print writers, or whatever else you like. And what you send into one socket is available to be read from the other, and vice versa. So it establishes this controlled two-way communication between different points. And lots of opportunities for exceptions. If you bind to a socket that's not to a port that's not available, if the IP address doesn't exist, if the socket you're connecting to doesn't exist, if you create an input stream and hit end of file, right? All these things can give you exceptions, so you use lots of try-catch blocks, hopefully tactically, like around small sections of code. And you've been doing this in PA5, so this should be recent memory. But if you broke PA5 up and you said, I'm going to make the graphics, you worry about the sockets, make sure you go back and look at the socket part. Okay, because there'll definitely be sockets on here. And then client-server model is you know, what we've been talking about basically. Is what you implemented in PA5. But client servers are also, you know, PuTTY and the Linux server, the SSH daemon on the Linux server that we connect to, or the LPR command in a print server on Linux, right? So I can say LPR and it reads from standard in, and it's going to send it to the line printer, right? Or I can say LPR file name, and it'll take that file and send it to the line printer. And I don't have a line printer connected to this, right? But it'll still talk to the line printer daemon, and in this case it would queue it up, and then when I get home it'll find my printer and send it out. Right, so there's I don't know where my printer daemon is. It used to just be LPD. But yeah, so that's another example of a client server. Who is server? You send them name of a host to it, and it sends back information about who that is. So it's a standard model that pops up in lots of situations, and generally we think of the server as kind of always available, always running, so it gets created first, right, just like PA5, and then clients come and go. Client makes a connection, does something, leaves, the server is still there, and typically the server will handle multiple clients at once. So the SSH server on linuxengrcs.com can handle lots of connections at the same time, because it makes a new process for each bash session, each shell session. And know how to write comments in code. You might see a question about that. So // or /* stuff */ That's your comment.
Should we specifically know about /*?
No, so I won't ask you about that. There is this thing where we can do comments like that. And then if we run our Java code through JavaDoc, it will pick up on these and interpret the comment in certain ways that lets it produce that Java documentation. So I'm not going to ask you about that. Although next year I think I'm going to require people to do that, because that would be cool. Because it's fun to get pretty documentation. No, that would be fun. I'm also going to do ODPs next year for 223, I think. So any questions? You got 6 programs, full programs or pieces of programs, and then 15 multiple choice.
How does server socket and socket differ?
Server socket, you specify a port. Socket, you typically specify a port and an IP address. So server sockets are created on your current machine, and they accept connections from others. But here's one machine. Here's another machine. So I make a server socket, it's got a port number. On my other machine, I make a plain old socket, which is supposed to go to host 1, port 1, 2, 3, 4. So it talks to this machine and says, hey, is there a socket over there that's accepting connections? And if you call the accept method, it will say yes, and so it creates a new socket, and these two sockets get connected to each other. So server sockets accept connections, and they return plain sockets, which can be connected to other sockets.
Does that connection technically have 2 lines to it?
It's a two-way communication. I think it's probably 2 lines in some sense.
Because I assume so, since that's an output and input stream.
Yeah.
So they'd be separate.
I'm curious what the description of server socket versus socket. Server socket waits for requests to come in over a network, performs some operation based on the request, and then possibly returns the result to the requester. That's pretty generic documentation, man. That's like almost every method out there. And then socket, it says, implements client sockets, also just called socket. Socket is an endpoint for communication between 2 machines. That's the wording from the old C manual pages. It always seems kind of sterile to me. So server socket waits for requests and then returns a socket, basically. And this is pretty cool. There's an SSL server socket. So that's a secure version. So that's a good example of class extension. Right? It's basically a server socket, but it's got this extra layer on top for doing secure communication. But it's not reinventing the whole server socket class. It's just adding to it.
What does abstract mean?
What is what?
Abstract. Oh.
Abstract. So an abstract class cannot be constructed, as far as I know.
What does the abstract keyword mean?
Let's just try this. I think it will complain. Oh, didn't complain.
Is it strange that it compiles?
Yeah, I thought it would say that you can't actually construct it. Alright, yeah, so you can't actually instantiate it. So it's there so that you can extend it, right? But you can't actually make something of this class. So I think that's the definition of abstract.
So we can make our own class and use that class?
Make your own class using that class, yeah. Alright, so the constructors are used only by the subclasses.
What's the advantage of abstract over no?
It basically lets you set up the framework for a type of class and provide some pieces of it, but you're saying you have to extend this and add to it. Right, so all these methods are abstract. Yeah, we didn't get into abstracts and we didn't get much into implements and interfaces. But again, we're doing about that much of Java. But a lot of things like interfaces, right, set up a kind of a blueprint for a class and can provide you some of the code, but also requires you to write other pieces of it. And abstracts are basically another version of that. Just giving you some of the framework that you need, but then leaving you to add more detail. Some other stuff?
You're always just going to cover what we discussed as possible topics for the museum, right?
Mm-hmm.
How does synchronize work?
How does synchronize work? I started to play around with this a little this morning, and then decided it would take too long. But right? So you can synchronize a block of code with an object. And I think of the object as like the flag that you're taking and saying I'm the only one who can run this code. So it can be any object as long as others are using the same object. And once you synchronize on that object, nobody else can do anything. So let's see.
I forget, was HA defined in another class somewhere here?
Yeah, so HA was just a random class.
Blank one?
Right.
I just wanted to know if it had to be defined or not.
Yeah, and usually you would use something more meaningful, perhaps, but it's got to be the same object that every thread is using. Otherwise, you're synchronizing with different flags, and you can both take them at the same time. Yeah.
Is it synchronizing on the entire object or just the method that is?
Say again?
Is it synchronizing, like, if you have multiple messages of an object, would it synchronize the entire object and every piece of it, or just...
So this is synchronizing this block of code, right? So just these 5 lines.
Okay.
And the H is just an object. It's not actually, H is not being synchronized somehow. It's just being used as a flag.
Okay.
So you could use this, for example, if you had multiple threads all with the same, notion of this, or something else that makes sense.
If there are threads requesting like different parts of this object, will it still wait for this block to be done before it?
There's not really parts of an object.
No, I just mean like if there's a different method in that object that a different thread is calling.
So it's strictly these lines of code, right?
Yeah,
So you can synchronize methods.
Or will it wait until that block is done before something else acts?
It'll wait until this block is done before anything else that says synchronized on the same object can start to execute. I'm trying to think if there's an easy way to put together a quick demo. Maybe. I don't know if I'm going to have time, but we can do this tomorrow.
You don't necessarily know what flag is yet either.
No, we don't. I'm going to have to figure that out really quickly.
You said synchronize takes an object.
Mm-hmm.
Got a couple syntax errors.
Yeah, give or take. So what I'm hoping to head towards, but I'll probably do this tomorrow, is have 2 threads, right? Each which basically sleeps for a second and then prints out a message. But that print block is going to be synchronized. And one of them is going to wait for user input, right? And once it's waiting for user input, the other one's going to block until the first one gets its input. How'd I do? Oh, lots of errors. put that together. We'll play with it tomorrow. So tomorrow's our last day. We're kind of done with the review, so I was thinking I would probably talk about some C++ just for kicks. It's another object-oriented language.
Can we talk about something I heard called Clean C?
Clean C.
I think it's a kind of programming language used in something called Lua.
I don't know Clean C.
I heard it's an extension of the C programming language.
Yeah. Not familiar with it.
Yeah, I figured a lot of that stuff.
Yeah, how to clean your C drive. Stack Overflow. Not a real question. Yeah, I know. Oh, it's by Steele. Okay. Can be compiled by standard C compiler in C++.
Apparently it's a dynamically allocated language.
Interesting. Declaring void func declares a function that has been specified.
And
Prototypes
that's
are
really
required.
because it's used in mod I'm using in Minecraft. Called
Oh, okay.
Just random questions.
This is talking about C++ versus C. If you got some information on it, bring it in. We can look at it.
Sure.
That would be cool. We can talk about Rockstar. That's an awesome programming language.
What are they usually used for?